Finally, we have our programming problem. We're going to write a program that'll take some statistics on an image and inverts the image as well. To understand what this is asking us for, we first need to understand a little bit more about images, in particular simple grayscale images. I mentioned in our background discussion that an image is made up of pixels, which is essentially just a 2D array of numbers. If you have a color image, you usually have 3 dimensions, and the third dimension is RGB, for example, red component, green component, or blue component. And there are some other schemes for that. But for grayscale, a pretty typical standard is for grayscale to have one 2D array, and the number in the elements represents the shade of gray, somewhere between white to black. So you have an n by m pixels, so rows by columns. There are n rows and m columns, so rows by columns of an image. And each pixel has a value from 0 to 255, so an 8-bit number. You can see, if you think back to old video gaming consoles, why the color palette was tied to a number of bits. An 8-bit game, a 16-bit game, because that's how many discrete steps of that color you can represent in a pixel. So that was a limitation that was at the forefront in a lot of years ago at this point. A couple decades ago. These days data is much cheaper, and so you don't run into usually color bits counts less than 32 or 64. So for the grayscale images we are looking at, it'll be a value of 0 to 255 in each element. The black color has a pixel value of 0, and the white color has a value of 255. So between those two extremes, or ends, between those two limits is a shade of gray. So 127 right in the middle is 50% black, 50% white, so exact shade of gray. Here's an example 4x4 image, meaning there are 4 pixels on the columns, or sorry, 4 rows and 4 columns. So it's 4x4 pixels, and the value in those pixels is based on the discussion we just said. So black is a 0, white is a 255, the gray tones are somewhere in between, such as 127 or 160. The scale of this is slightly off. They look rectangular in a few places. This should be exactly square, and we'll see what that looks like in a moment. But these are the values. To create this file, we have some text, but let's think about what it's asking us to do. So this program wants you to create that image that's shown here, to invert it, and to take some statistics on the pixel values. This image that we're going to work with, the type of that image will be a .pgm. So remember, we can just change a text file to a different type, and it will be read differently by Windows. So what's highlighted here is the information we need to generate that picture. So I'm going to copy that, and I'm just going to go to a folder here and start a new text file, call it img1. I'm going to leave it at .txt for now, but let's open it and paste that in there. So this is exactly what was in the lab, paste it in there. There's some header information saying there's a comment saying this is a 4x4 image. You need that P2 as well. Then it's 4x4, the max value is 255, and then here are all the pixel values, 4 values per line. So let's save that. And I mentioned at some point, perhaps I haven't, I mentioned in the requirements for this class, I think, so you may not have come across it yet, was that we can open this image in a lot of ways. For us, the easiest way is just to use a very simple program called irfan, and we'll see that in just a moment. It has a, you saw when I changed this to PGM, there's this kind of weird splatter. and it's an IRFAN view, IRFan view. So IRFan view. You can go to their homepage. It's a free, totally free software. You can just download and install. That's the software I'm using right now. And so you can see the text file that I just copied and pasted that text into and then changed it to a PGM. I can double click it, and this is the IRFan view program. Now the screen is not too impressive. You see a dot kind of in the middle probably. That's our image, but it's very small. A 4x4 image is very, very small. If you think about modern computer monitors, you might have 1920 by 1080. That's just the number of rows and columns. So multiply that together, you have a whole lot of pixels, way more than 4x4. So we need to zoom in quite a bit to see our image that we just made. And so there's a zoom in button right here. It resizes your window when you do that. One issue as you do that is it tries to blur it and make it look nice. You can go to View, Display Options, and then uncheck Resample for Zooming. Then keep zooming in. Now it'll show you directly the pixels and not try to blur it and make it look nice. We want to see it exactly as it is. So this was the text. Here's the image. And you can see that this image is identical to so if you use your scroll wheel in IRFan Viewer, it will try to move to the next file, and depending on what the other files are in your folder, that could cause a lot of issues. So don't hit your scroll wheel. Let me get the image back up. I was attempting to scroll up in the PDF. But you can see that the image pixels exactly relate. So 0 is black, 255 is white, and then black again, then white again. That 127 here is a tone of gray. And there is a cursor where you can actually look at the information in each pixel. Maybe just click on it. Yeah, if you, let's see. Yeah, if you click and then look in the header bar here, if I click and hold on the black, you see RGB 000, index 0. If I click on the white, RGB 255, 255, 255, index 255. If I'm on the gray, index 127. So you can see in the header bar what the value of each pixel is. So make sure you turn off that blurring, and you can just look in the header bar to verify the value of the pixels. So yeah, 86 down at the bottom here. So this is a very, very simple image program, and we have a very simple image that we're going to be working with. Here you have some description of those header lines that are definitely required in your text. So this is what your text should be here by the time you create this output. So let's talk more about what you're doing for this problem. I made this image as an example, but what you will want to do is create an output with the same format. So the first 4 lines will be identical, there'll be an identical header, but this array, the last 4 lines are going to change. So you will be creating an output stream, you'll be sending out some values, making sure it's formatted identical to what this needs. If it doesn't work, or sorry, if you don't put it identical, it won't open in the program. So your assignment is to create the data in your program. You do not read it in from a file. So it is more difficult than you may think to read in this array of information. So what you'll have to do is create a 2D array in your program right up to the top and load up each element with these values. So image, say your image array is a 4x4 array. So element 00 needs to be set to equal to 0. Element 01 needs to be 255. Element 02 needs to be 0, and so forth. So load up each element so it's exactly this by brute force method, element at a time. So it will be 16 lines long. I understand it doesn't look efficient. It's not, but given the tools we have now, we're just going to hard code your initial data into your C program. So before you do anything, make an array with this information in it. Okay, make a 4x4 array with that information in it. You want to, using that information, you want to display some statistics on it, create its invert, and then output two separate files. The invert means to take the value and do 255 minus that value, and that gives you the new value. So white will turn to black, black will turn to white. So you're inverting the grayscale by doing that. So you're going to make an invert function that will take your array and invert the pixels using this formula as given here. So that's just going to invert white to black and black to white and everything in between. So you'll invert the array and then write out that array into an image file. So you'll have img_invert.pgm. The first 4 lines must be the same header that you see up here. They must have these same 4 lines, identical. Then the last 4 lines you will write out your invert array. So you will have inverted this, and then you write out those values to the file. That file must be called a .pgm, imageinvert.pgm, which is described in this paragraph here somewhere. I was just looking at it. Yeah, here we go, imageinvert.pgm. So you must create a file with an inverted image. That means when you open up IR Fan View and zoom it all the way in, it's going to be opposite of this one that I'm showing you right here. The black will be white, the white will be black. So it must be opposite of this, or opposite of this picture shown in the lab. So this is the same image here. So you can compare against the PDF to make sure your inverted image is inverted. So 2 things you need to end with. One is your inverted image as a file, and then in a separate text file, you're going to have a second output stream to a second text file called outData. And in outData, you want to tell us the average of all the pixels. So average all those 4x4 pixels. And then we want to see the standard deviation of the entire image. So standard deviation is calculated by this formula here. So as you can see, this summing means looping in programming. So you're going to be using, during your looping processes, creating this standard deviation S. So you will have an average and a standard deviation, both displayed in your outData file, which will be a text file. Also in the outData file, you will display this information. So an average, a standard deviation, and then average plus 1 standard deviation is put in your calculated of average plus 1 times standard deviation. Put in your calculation for average plus 2 standard deviation, average plus 3 standard deviation. If you've had a statistics class yet, these values in significance make sense to you because you're familiar with confidence intervals. They're a description of how many of the values fall within certain ranges. If you have not had another statistics class yet, the meaning behind finding the confidence interval levels will become more clear later on. But suffice to say, these are statistics that would be desirable about a data set. So you need to interpret this formula and interpret how to pull it from an array, essentially. Your array, again, will be hard-coded. So set up your program to hard-code this array. You need 2 things. You need to output an inverted image, which is just done by inverting each pixel, so 255 minus the original value. So similar to our exercise where we flipped the array around. And then you also want a second output file that is a text file where you need to have the average, the standard deviation, and then these 6 points of data calculated and output. A few parts here. Make sure you spend some time planning in the beginning of your process here. It gives you some guidance on what kind of functions you're going to make, such as the invert function, which will invert and output that file. The average of the image and standard deviation of the image functions will take the array and calculate those things. And then you need to ultimately output all of this data to a separate file. So a couple pieces to keep track of. Make sure you're clear from the previous examples how to work with arrays. There's nothing programming-wise out of the ordinary here because it's an image. All it really is an array. And the data, to make it an image, is just having these 4 lines of header in it. And then you have 4 additional. I'll also note you can open this type of image in other image viewers. If you feel more comfortable with something like Photoshop, you can use that. But I will only be able to provide assistance in this video, at least, with the IR fan view, and I can't guarantee other software is going to work exactly right to show you the pixel by pixel view. So just be careful about that. It is a free program that you have access to. So make sure to get on Discord if you want to discuss this with your classmates. It's a significant problem here, but nothing you can't handle. We've done a lot of problems up to this point in the lab, and we're leaning more towards applications. So images, statistics are all great uses of computer programming. I'm looking forward to hearing from you, hearing chatter between you and your classmates about this problem, and then I look forward to receiving your commented code. One topic to go after this, so keep up the good work.